Hello, and welcome to Srijan Wednesday webinars. If you're joining us for the first time, this is a community initiative by Srijan Technologies, where you can tune into some great sessions on topics ranging from front-end technologies, UI, UX, mobile apps, to media, community building, and digital marketing. In today's webinar, we how to improve the performance of your Rails app. Our speaker today takes you through how to identify performance bottlenecks and understand the issues involved. He'll also share quick tricks to solve issues and supercharge your Rails app. Our speaker today, Cruz, is a food lover who speaks about Ruby and other programming languages at conferences around the world. He fixes Rails performance problems to help SaaS owners keep their hard-earned customers. Before we get started with the session, I would request all participants to please type in any questions that you have during the presentation, and we'll take them up in the last 15 minutes of this session. Also, please don't forget to take this conversation live on Twitter using our hashtag SrijanWW. You can share your thoughts by tagging us in your tweets using our handle @Srijan and Aaron's handle @Mr. Aaron Cruz. That is MrAaronCruz. So without taking any more time, let's get started. Aaron, over to you.
Hello, I'm Aaron. I'm going to talk today about some easy things that you can do to your Rails application to kind of up performance and get some easy wins there. What's happening here? There we go. So I'm Mr. Aaron Cruz on Twitter, as was just said. I have been doing performance fixes, but more recently I've also been building bots for startups. I feel like kind of a lot of our applications might be replaced with bots in the near future. It's fun stuff, and you also get to use Rails or whatever kind of back-end technology you want most of the time to build them. So it's fun, and it looks like it might be kind of the future. I'm into it. I've been doing Rails for a while now. I switched out of doing other things because it's the technology that was the most interesting. It seemed like something that I actually enjoyed to do, which the kind of the programming languages and framework were kind of tedious and made me feel kind of awful. So I've been with Rails for a long time. I've been using more Elixir these days, and actually I have a contract in it right now, and I'm having a lot of fun with it. But I'm still doing Rails most of the time. Good times. So I want to ask you guys a question, if it's possible. What experience level you're at, so I know kind of where I can direct things, kind of where to take more time, where to take less time. If you're at any level, I think you can get some good things out of this. Best for beginners probably, but intermediate definitely, and maybe some good stuff for some experts. I don't know where this would show up if anyone is typing anything in, but I am not seeing any responses. So I am thinking that I am going to assume that you are all beginners and continue on with that thought in mind. Or intermediate. Let's go there. I'll go right in between. Good times. So the first thing that you should do before you're doing any kind of performance gains is to figure out where you are right now. Kind of figure out what the status quo is. It's important to measure what you have, what is slow, what is fast, what is working for you, and then kind of look at what that is. If you don't measure what you have going on right now, it will be very, very difficult to find out kind of what you can improve upon in the future, or if you have actually done something to improve performance or possibly make your performance worse without even knowing it. So get some profiling in there, measure some things. It's important. One of the things to do is when you do find out some of your bottlenecks, it's best to just kind of attack the big things, the big problems, the slowest things, even some of the low-hanging fruit. Just go in, fix those things. You might even find out that some of the harder, some of the not big performance things are not worth your time for the improvement that they will do. But if you're not doing any of the profiling, it will be very, very difficult for you to know at all. So there are a few different ways to do profiling with the Rails app, but probably the easiest and the most well-known is using a service called New Relic. I use New Relic. I really, really like it. It is kind of amazing, the insights that it will give you. It does a lot of things, not just in your controllers or in parts of your Rails application. It does a lot of stuff. So here's an example of one of the pages from New Relic's dashboard. And you can see on the left, those are all controller actions. This is actually an API for an iOS app. I'm guessing from the name. I stole this screenshot, so I have no idea where it came from. But you can see that those are like index actions, a CPU action, and the amount of time that it takes to render those things. And you have graphs on the right, and you can see kind of things, how they are working over time. Here's another screenshot of, you get kind of a regional view. You get to see where your app is slow or fast in different regions, the load time, all kinds of things. There's a lot of different things that you can get from New Relic. It's some of the things you can get. It'll show you some slower controller actions. You can look at kind of analysis of your slow SQL queries. You can see how much time you've different database calls, which is awesome. And if you're hitting kind of external APIs, it can show you maybe those are performance bottlenecks. Maybe you're needing to do things to kind of speed up those interactions that you're having with those services. So it gives you a lot of insight. There's a lot of other things that it will give you as well. The list is just, it can go on for hours, so I'm not going to go any further with it. Another great thing about it is they have a free tier. So there's, it gives you, I've gotten pretty far with the free tier before. If you're using Heroku, you can just do, Heroku add-ons, create New Relic, and it automatically just kind of sets you up. The way that you install New Relic is using the New Relic gem and then downloading like a YAML file, and then you're good to go. You don't have to do anything else with your basic setup generally. It's amazing how easy it is to get so much insight into your app. This isn't an ad for them either, but it's an ad for the free stuff. So jump in there and get free. So metric foo. This is it's a suite of kind of performance gems where it's not performance, sorry, just for code quality gems generally. That it runs all of these code quality gems, like 7 or 8 different ones, I think. There's plugins for other ones. And then it gives you kind of a nice dashboard of kind of all of those things. So, for example, it uses Reek is one of the gems it uses to find different kinds of code smells, and cleaning up some different code smells will give you some kind of performance wins or help you kind of just maintain your code. This is another gem called Kane that looks at your code quality, and if your code is crap quality, if you just have dependencies everywhere, if you do have any kind of performance problems, it's going to be very, very difficult to fix any of them because you're going to be so tied into your infrastructure, so tied into your spaghetti code that it will be really, really hard to change anything. So these things can help you you can run them maybe every time you finish a feature. Maybe you can set up some kind of a task that runs every time you're running your tests that also will run some of these things kind of to help you along your way, kind of like doing TDD but with code quality. And then there are, like, as I said, 7 other gems or some more, I don't know, that it also uses. You can also use these gems outside of metric foo. Yeah, it's good stuff. So another tool that is really cool, but I will get to it a bit later, is something called Rack Mini Profiler, and well, it's good. Love it. Probably saying it's good a lot. Sound like Trump a bit. So let's jump to win number 2, or as some would call it, the second win, the database. So I find that kind of in my performance issues that maybe 80%, 90% of those problems stem from database issues. It's not like I'm not using a binary tree or crazy algorithms to do things. It's more just like I'm doing something stupid in the database. Fixing these problems, it's incredible how much you can gain from just some of these simple things. So what do we got? We got one of the most common things that I see is not using index when an index should be used. Maybe loading your entire data set instead of using the database to do things for you. Or if you're running kind of a large database, running your index from disk instead of being able to store the whole thing in memory. So that's kind of a scaling up issue. So we're going to hit that first one first. It's good to use an index. First of all, if you are a beginner, like I decided that you are from your answers to the questions, just to describe what an index is, it's taking a column from a table and making kind of like another table with that column that is that column, or maybe a combination of columns that is sorted in a certain way. So it's that column, like say it's your username column, and you're sorting it with, it uses a, generally, like I think Postgres's default is to use a B tree, like a balance tree, but some of them use other things. So it can, say you want to do it in alphabetical order, it can save just the username column in a fast algorithm with each column having a pointer to the table that or to the column on the table, to the row that it actually is from on the other table. I should have probably practiced saying that more because that sounded really confusing to me. It's just taking one column and sorting it and making it easy to find it and then going back to the row with a pointer. Yeah, well, that was the worst explanation. But indexes also have a downside. If you're creating an index, you need to store that data, that column, as many rows as you're needing to index on that other table. So if you have millions and millions of rows, billions of rows, then you're going to use that much disk space. If you need to keep that in memory, you're going to need that much memory to keep that index in memory and make it fast. Yeah, so there is a trade-off with indexes, but it's totally worth it in almost all of the cases. Pretty much, actually, all of the cases that I've ever looked at, indexes were totally worth whatever that trade-off was. The times that I decide to add an index, so when I'm thinking about does this thing need an index, is generally when I'm creating the table in the first place or adding columns to a table. What you can think about when you're adding a column to an existing table is, will I be using this column in a where clause or in an order by clause or a group by? Will I be referring to this column by name? And that's generally a good way to decide, yeah, then I should probably be indexing this column. It also goes the same with creating a table. You're like, I know that I'm going to need to do a date range, or I know that I will need to look at kind of the count of this thing or sort this by this username. So I'm going to add an index. The other thing is, if you are then kind of in your application code later and you're creating a new query and you realize that you are sorting by something new or adding something to a where clause with a condition, that's a good time to look through and see kind of if you have a column on that. So I'm going to show real quick kind of how to do that, just like a super fast way to look on Postgres. So I'm going to look at this, and then we have a page views table. So \d page views, and you can see at the bottom here we have these two indexes right here, and you can see that it's using a B tree on both of them, and all the way to the right is the column. So I can see that my user ID column is indexed in this table. So another question that you might be asking is how do I actually find these problems? How do I find these places where an index is needed? Like, what is happening? What is slow in my database? So I know that at least in Postgres and in MySQL, there is something called a slow query log. The slow query log is a place where you can set some kind of a threshold on milliseconds or seconds for how long the longest query should be. So if I said my slow query log, the threshold was 1 second, it would log the SQL for any queries that took longer than 1 second. This is a good place to kind of just set it and kind of forget it, maybe on development. On production, it does actually take some overhead to do logging, so you kind of want to set your threshold pretty high so it's not constantly logging and slowing down your query performance. To do this in MySQL, you can go to generally here. If you're using a Mac with like Homebrew, it generally puts it somewhere else, but you're just looking for this my.config file. And then you can add slow query log 1. It shows the path to the log, and then your how much time. This is 1 second. That is the shortest, or the longest. Sorry, no, the shortest that it will query. Sorry, log. Jesus. And that last thing is pretty awesome. It says log query is not using indexes. This will do that, and that's another way to find where indexes need to be added to your queries. So MySQL also has a tool called MySQL dump slow. This is just kind of a command line tool to print out your MySQL slow log in a nice way. You can use different things to tell it to sort things or which things you want or limit it, and it's a pretty cool little tool. Here's a few other tools that I haven't actually used before, but they're probably cool, and they do this kind of long query analysis. Postgres also has a slow log. Go into the postgres.conf file. I think this is in milliseconds. Save it, reload your server. You need it to reload with MySQL as well. It's really important, or it won't pick up the change, the config file. And then your logs are generally located in this var lib. You can see the path, I hope. So another thing that you can do is you can use explain to look at different queries that you have and kind of see what the query planner is doing, if it's using indexes on things, if it's just doing full table scans. There's also an explain analyze that will actually run. So explain does not run the query. It just analyzes, or it just looks at the kind of what's happening, what it thinks will happen. Explain analyze actually runs the query and then can tell you things about how much memory is being used, if there's too much memory being used, and all kinds of other stuff. So we have this users table that we just looked at a second ago. We actually looked at the page views table. It's a users table, has a username, and then a friend count. There's a page views table that has a user ID to kind of join it to the users. And what we're doing here is we're just joining the two tables together in the user ID where the friend count equals 50, and just grabbing a few of those records. So this table I created, it has millions of rows, I'm pretty sure, maybe 1 million rows. So this is what it looks like with that explain thing. What do we got? Can I get my guy over here? Oh, nope, looks like I can't. Anyway, so from the bottom to the top, you can see at the execution time at the bottom is how long it took. So this took 50.5 milliseconds. It is using an index. The way you read this is from the bottom to the top. You can see that it's filtering on friend count. It's using one of the indexes, and then you can look, if you look down the lines, the index. Where is the first one? I can see it. So that sequence scan, which is like, I think like 6 lines up, you can see the rows, and it's hitting around 4.5 million rows it has to hit to do this query, which is a lot, and that's why it's taking the time. So we're going to add this this index on user ID, which is on the page views table. And we can see that the execution time goes down to 0.355 seconds. That's a difference from the 15.5 from earlier. And yeah, and you can, where is it? This index only scan is only hitting 7 rows, which is awesome. So we have actually got a 44 times speed increase by adding 1 index. And that's worth it. So I've worked on kind of rescue projects before where the site was kind of unusable because it was so slow to load, and I've just added a few database indexes, and like the site was fast, and I collected my check, and I was like, thank you very much, when it took like very, very little time to fix it. And you will find also that in your old kind of legacy apps that adding a few of these indexes, it's amazing how much improvement you'll get. Another problem that we can run into is loading too much into memory at the same time. So I've had this problem before, like instead of having the database sort things, you try and sort it yourself, or I've tried to do using sort random and grabbing something, but grabbing, like instead of using sort random, I've taken a list and then grabbed a random thing out of it. But you can actually do kind of sorting random in your database. You can sort in your database. You can group by things in your database. Rails, like enumerable, Ruby enumerable, and the array class have some really, really neat things in them, but you can do so many of those things just in your database, and then you return 10 things instead of 10,000 things, and it's amazing like how much memory you save. It's good stuff. So we will move on to win number 3, which is fixing n+1 queries. So if you are trying to get kind of an attribute of a join table, so if you have maybe orders and you want to get you join the products to the orders, and then you want to get like the product title, what that will generally do if you just get the orders and the products is it will go for, you'll get all of your orders, and then it will look up each order or each product and then make a query for each individual one. So if you have 100 products, you'll have the one query for the order, and then you'll have 100 queries for each product, and that's what n+1 is. The orders are the n, and then the original query is the 1. So Ruby has this, or Rails has this cool thing called includes, that if you use this, it will kind of do some preloading magic for you. So here's some example code that we have. We have a post. So we have, this is like maybe a publishing platform. You have an author that has many posts. Posts belong to authors. We have this published scope that just kind of orders things and makes sure that it's published. So the way that I described earlier to do it would be you get all your posts, and then each post you print out the post title and the author name. So author would be, of course, the joined author. And this would do one query to get all of the posts, the articles, and then it would do for each round around that each block, it would do one extra query. So you get 101 queries for this. If you use includes instead, you includes that author, then it ends up doing one query for the posts, and then it takes all of those post IDs and does one query to the author table to get all of the authors with those post IDs. So it's 2 queries, and then it does some magic to combine the stuff in the background, and you get 2 queries in the end instead of 101, which is a pretty huge performance win. You can generally see when this is happening in your logs. If you're watching your logs, it will you'll see a lot of output all of a sudden that are all that all look very, very similar. Find out where that happened and try and use an includes. There's also joins, which is good for, it doesn't actually preload the records in. Instead, if you have some sort of if you're joining on a table but you don't need any data from that table you're joining on, so for here, for example, we have we want to get posts from authors that are younger than 20. So we can join the author table, and then we have a condition on the authors table. This would be a good spot for an index, by the way, on birth year. And what that does is we get to use the relation, and it just works out really nicely there. The problem, though, is if we wanted to use that author data, that it would then be the n+1 problem. There's, what is it called? There's another one that you can use, references. I think that you can do a joins and then references if you want to then get the benefit also of the includes. So there are a few tools to use for finding these n+1 queries. One is the logs. Another one is this this tool called Bullet, where it's a gem that you add to your gem file, and then it will log n+1 queries that it finds into your logs. And then you can tail your logs and find, or run some sort of a grep, filter your logs and find out where these n+1 queries are happening. So I like to do a lot of kind of aliases in my CSHRC or my bash RC, should be .bash RC. I use a lot of aliases. I love aliases. I hate typing things that are that long because I end up just not doing it and not caring about it. So let's look actually what's going on here. So we can run a what is it, grep alias, and I have 129 aliases, and you see therefore things like production log, dev log, staging log, just a ton of random things, and most of them I forget over time. I should probably clean them up, but I love them. Whenever I start kind of with a new thing, I love to use these things. Do it, it's great. So on to another win, view rendering. So it turns out, before I started doing any kind of profiling on this, I had no idea how slow like partial template rendering could end up being. It's kind of amazing when you have a lot of tiny partials how much of an impact that can make to your rendering time. Like, it's crazy. So I wouldn't have known this without doing some sort of profiling. And what I've used for profiling is this rack mini profile I talked about earlier. Love it. It's a gem. Add it. Here's the page, so you know what the page looks like. See Sam Saffron's name. Woo! Okay. So mini profiler gives you a couple of things. It gives you flame graphs. What flame graphs are is it's a map of your methods, how much time is spent in different methods, and those methods' dependencies on other methods. So, it gives you, once you understand how to read it, it gives you kind of a really, really good insight into where you're spending a lot of time in certain functions, and they look pretty cool too. So I was just at RubyC, and Miha gave a pretty cool talk on flame graphs, super high energy talk. I learned a lot about flame graphs that I had no idea about, and I really highly recommend just watching this talk. It's pretty short too. I think it's like 25 minutes or something. But it's a super nice intro into flame graphs. So another thing that Mini Profiler gives you is this little profile window in your app. I would set this on some sort of a like an environmental variable that says like Mini Profiler equals 1 when I'm loading Rails to show it, because it kind of can get in your way. And then, as with anything, when something starts to get in your way, you tend to just want to turn it off and never look at it again. So it's kind of good to have this around when you need it, but not always have it on. But you can see if you look at this that you have this. You can see how long it took the page to render up in the upper left-hand corner with this 88.9 seconds. If you look down, you can see each action, how long those took. You can look at like specific partial templates. You can see your query time and how many queries were run on this page. It's pretty amazing, the insight that you can get. You can see like which partial is taking you're rendering it 100 times and it takes like 20 milliseconds every time, which is, not awesome. So you can really narrow that down and figure that out. And what you end up what I've come to the conclusion of is like your views definitely should be as dumb as possible. Like really, 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 really dumb. They should not do computation. They should just kind of have values essentially in them. So I've come to lots of apps and seen some horrible, horrible things with people inside of templates using conditional unless else statements, which just doesn't make any sense. Unless else, please don't ever use it. It doesn't actually make any sense at all. It's confusing to look at the kind of the backwards logic. I would see like embedded unless else statements. I'd see like actual active record models being used inside of views. And the thing about it is that it's really impossible to, even if you find a performance bottleneck, to pull any of that logic out to fix that problem. So if you keep that logic out of your views and just keep them like kind of a container to show whatever data you have, that just will help you not find your performance problems, but fix your performance problems. So one way to do that, one thing that I've used a lot is the Draper Gem. The Draper Gem uses kind of the decorator or presenter pattern to do a lot of your domain logic that you would be doing in these conditional statements inside your views, but in an object that is inside like your domain, your application's domain. So you can separate things easier, you can pull things out, you can refactor things, where in the actual view that's really, really hard to do. So your views become easier to read, and so does the rest of your application. And if you do find performance bottlenecks, it's generally in a class that's easier to pull stuff out of and refactor than your view. It's also much easier to test a presenter than it is a view, I found. So I use Draper for models and all kinds of things even. I like the presenter pattern quite a bit. Kind of super into it. Love it. So let's move on to this next win. It's caching. The first time we will talk about caching. So view caching in Rails is pretty cool. Rails makes it really, really incredibly easy to do caching. Even almost so easy to a detriment at some points, but it's to do like kind of simple things and to speed up. Like if you're using Mini Profiler and you see that a partial is slow, like if you can't really change what's going on, you can cache it. Just cache it. Caching, of course, has a lot of trade-offs as well with expiring caches and things like that. But if you keep these in the way that Rails does kind of the partial caching, the template caching, it makes it kind of, you don't run into those problems as much. So here's an example of doing caching in a Rails view. This is some ERP code. We have products, which I'm guessing is a active record model. And you call cache directly on product. And what that does is it calls this cache key method of whatever thing. So cache can take a string. I think it can take an array, or it can take an object that responds to cache key. Active record models respond to cache key giving, I think, their ID, probably their class name, and then the updated at timestamp. So what that means is if the key changes, it's going to render this section of the view. So if you update your model, it's going to update the updated at, and then this will be recreated. So you don't really have to worry about, in a lot of cases, kind of expiring your cache by yourself, because Rails will do that for you. What's going on here? So cache key, it's awesome. Use it. One of the problems, actually, that's what I was going to go into. One of the problems with this that sometimes comes up is if you have some sort of like user-specific data, if you are caching something that could possibly be cached for all of the users. This actually just happened recently with Steam, where their caching went kind of haywire, and they were caching like users' profile information and stuff like that. So if I came onto the site after you did, I would see your profile information. So you do need to definitely watch out for things. There is a Rails cast about caching that I watched ages ago that he goes into pretty good detail about using some of this caching, and also how to deal with that personal information sort of stuff, how to take care of that stuff with JavaScript if you really need to worry about it, which sounds awful and kind of is, but it's totally worth it in a lot of cases. So our next win is model caching. So you cache your templates, you can also cache your models. I kind of maybe overuse this method. It's pretty awesome. It's called Rails cache fetch. It takes a string, an array, or something that responds to cache key, and it will, if the thing doesn't, if that cache key does not exist yet, it will, in the first case, you can see it gives you today if today exists. Today obviously exists because we wrote the cache there. With cache.fetch, the next one, you can see city. City doesn't exist, but if you give cache.fetch a block after the key, if the key doesn't exist, then it will execute the block, and then it'll cache that and then return the thing from it. So you can see that happen here. City doesn't exist, and then we get Duckburg back when we try to fetch it again. What it's not showing here is that cache.fetch city with a block also returns Duckburg. So yeah, you can just cache fetch on a model, and it will give you stuff. It's good. I've used it a lot for doing kind of external calls to APIs. I've kind of re-implemented it myself a bit when I don't have it because I love it so much. And yeah, it's great. Cache.fetch. Here it is, using it inside of an active record model. This is using the array. It just combines that array into a key. And you can also give it an options hash as the second part, which has an expires on it. Is one of the things you can do. One of the keys is expires, and it will just expire it. So say you have a lot of users hitting your app, and you have some data that can be stale for 3 minutes or something like that. You can just make it 3 minutes, and then every 3 minutes it will recache itself. And you can see that block is going to be returned, and it's calling out to an external API. So it's pretty good stuff there. Catch.fetch. I love it. I love it so much. So the next win that we're going to go into is JavaScript and CSS. So a lot of people these days, like me included, are using things like Bootstrap or Foundation or Semantic UI, jQuery UI, a lot of these frameworks. The thing is that these frameworks come with kind of the kitchen sink, like the entire everything. And if you're including the entire everything, your initial page load is garbage. Like you're loading hundreds of kilobytes of information, and it's a horrible user experience. It's also a horrible developer experience. If you're having to recompile that bundle every time with your asset pipeline, it makes your page refresh take, I don't know, 5 seconds instead of 1 second, which can just add up over time. So delete what you don't need. Get rid of it. If you're using a gem for, like, if you're using the Bootstrap Sass, or you're using I think there's probably a Foundation gem. If you're using the jQuery UI gem, it's possible they tell you how to just require specific things. Maybe you just need drop-down and modal. That's all you have to include, and it will dramatically improve your page load times. And that's it's not just important for development. It's not just important for your users liking your app's experience. It's also, Google finds it very important how fast your app loads. I can't remember how many milliseconds, maybe 200 milliseconds or something like that. If it takes longer than that, then Google's kind of they will penalize you on your SEO. So there's a lot of good reasons to get rid of the stuff that you don't need. It's also just extra dependencies and code in your code base that you'll have to deal with at a later time. So get rid of it. So in conclusion, I'd like to tell you guys to profile. It's really important to know kind of what's happening right now. And then you'll be able to see if you have made improvements, if you've made things maybe worse, because a lot of the times maybe you think that, oh, this is an amazing algorithm that I've added, or this index helped me, but you'll find out actually that it actually slowed down your app. And you can actually add into your build something that you can add performance tests that will show you the change over time. You can make graphs of those things. There's a Destroy All Software episode from, I think, maybe the first season about looking at kind of performance change over time. That's pretty interesting. Get those slow logs going, fix your database problems, the indexes, add them, find out where you need them. You'll get an incredibly dramatic improvement. It's great. Cache, continue to cache more. Yes. But also read up about it, because there are trade-offs. I kind of went a little bit light on the cache trade-offs. The old joke with the hardest things in software. I don't want to say the joke, but yeah. I feel like I'm trailing off right now, so I'm just going to do this. And thanks for watching. And if you stay through the whole thing, thank you. And yeah, so I'm going to hand the mic over to Daisy. Maybe.
Thank you so much, Aaron, for that very interesting session. Moving on, I'm pretty sure there'll be a few questions that the listeners would like to get answers to. But before we get moving to the questions, Aaron, could you just do a little recap of what you've covered so far?
Yeah. Well, what did I cover? Let me look here real quick. So there was different profiling tools that are good. React Mini Profiler, New Relic. Really, just set up New Relic now. Don't waste time. Just really go in and set up with your app. I've gone over and over again with indexes. I'm not going to talk about those anymore. The slow query log, like set it up. You'll be surprised probably. N+1 queries, there's quite a bit of information out about them. Like, and also what I recommend is looking through, like, I guess this is something that I didn't cover, but it's something that I always surprise myself with, is read the Rails documentation. Like, I often go back to read the active record, just the main Rails documentation for active record, and I'm like, that's a thing, like merge? What is merge? And I just actually, like, researching this, learned about, like, eager load is something that does something similar to includes. Like, includes uses eager load, or it might use preload. Eager load is the same as, it's very similar to join. It's like, there's so much stuff that's going on that you'll find out, oh, I can actually add things to associations that way. Like, read the docs, read about caching. There's a great, like, section of the Rails documentation about caching, like, just as a nice intro. And yeah, read the docs. Yeah, Rack Mini Profiler is great. Draper is great. And Rails cache.fetch, I think you probably realize I like it. Yeah, I think that's my recap.
All right, so we've got one question from Sinan Kessin, and the question is, how can we profile our Rails app on Windows? As we all know, Ruby is slow on Windows. How can we see the main cause of this slowness, especially Rails-wide?
Especially what was the last part? Especially what?
Especially Rails-wide.
With with Rails, like, it doesn't, like, with Windows it doesn't matter. Like, you're still going to have the slow query log if you're using MySQL or Postgres. They're going to maybe be in different places. You can also use New Relic. Like, all of the solutions that I've gone over, I'm 95% sure that all of them would also work on Windows. These aren't Linux or Mac specific things. Yeah, and yeah, that's my answer.
So we have another question, and that's from Shrishti, and she says, can you please elaborate the application of model caching?
Yes, I'm still, yeah, perfect. So let's go, where are we? Is my screen still on here? I'm going to guess yes. What's happening? I'm going to go here. We're going to look at the actual slides so it makes more sense. Yeah, I kind of didn't really go into great detail and kind of what the use case would be. Where are we? So here's an actual, is that? Yes. So for example, if you have a kind of a large computation, especially, like, I'm actually not going to use that example. So if you have something that's having to hit a lot of tables, maybe like a count of something, in the end maybe you're aggregating some sort of count where you're needing to add things, and you find out that, or maybe you're needing to run a bunch of different queries together, or maybe you're then crunching numbers at some point. If that thing doesn't need to be up to date, like exactly for how things are at this moment, every time you look at it, maybe it can be 3 minutes old, maybe it can be 1 day old, maybe it's like some kind of daily statistic that you're getting from the database. Caching is something you can do. What is good to do is to create some sort of like this is generally what I do, is I will create a method that is like a list of something. So say I need a list of all of the orders for the day. I will make some sort of an order scope that has, like, that would be called today, and it would be just some kind of a date range for orders for today. And then I would create a method that is called like cached orders. And this would make it so I don't accidentally get cached things when I'm looking for not cached things. And then your cached method could either use the not cached things or the cached things, depending on if the cache is stale or not. So it's really useful for if you need something that doesn't need to be like the freshest thing in the world. You can decide on kind of what the expiration date is and do that heavy computing now. This is kind of actually a crap example now that I'm looking at it, because they're not really, it doesn't look like that competitor thing is actually an active record model. So this would just be kind of like caching like a remote request. And that's what I've used it for the most. So let's take a step out of model caching and into like external request caching. If you're going to hit, say, maybe you need some information from Facebook or from Last.fm, some kind of music data, or maybe you just have another service that you're running that you're trying to connect with. Something that's good to do is if that doesn't need to be information from this moment you can cache that, because there's a lot of overhead in communicating with external services. So that's where I've used caching extensively, is communicating with these kind of either APIs in my own kind of system or with external APIs. And hopefully I answered that question, because that was a very long answer.
Great. Okay. Thank you so much, Aaron. Now that we're running towards the end of the webinar, I would request those who still have questions to please email them to webinars@srijan.in. Thank you once again, Aaron, for leading such a delightful session. We're sure our attendees will find the tips helpful in getting a faster Rails app. A big thank you to all of the attendees for joining us today. You all have been a great audience. You'll receive today's presentation and session recording in your mailbox soon. As for our next webinar, you'd be getting a mail from us, so stay tuned. That's all for today. Thanks for joining us, and hope to see you next time.